This construction management webinar session is entitled Maximising Profitability in MMC from Design to Build in association with Dassault Systèmes. Our programme today. Managing scattered data effectively is a major challenge that impacts project quality and compliance. Companies struggle with vast amounts of information from digital models, site reports, and communications. Discover how centralising this data can transform your projects, learn how to connect stakeholders through a digital twin, automate tasks, and gain real-time insights to reduce errors and optimise costs. Our experts will show how this approach enhances collaboration, compliance, and productivity, and strengthens the link between design and manufacturing. There'll be a Q&A session at the end. Let me introduce our speakers. Abdullah Gulabi, Business Value Consultant AEC at Dassault Systèmes. Howard Bradfield, Account Manager at Trimec Enterprise Solutions. Gordon Stewart, Product Manager at Trimec Enterprise Solutions. And James Brown, Head of Digital Manufacturing at Prodtext. I'm Justin Stanton, Editor of Construction Management Digital. I'm your chair today. Before we dive into the webinar, there's the usual housekeeping to deal with. Please use the Q&A function, not the chat function, the Q&A function to ask questions of the speakers. Please keep questions relevant to this afternoon's topic. Our panelists will address your questions in the Q&A session at the end. Our panelists will cover any unanswered questions after the webinar. Please note that if you pose your question anonymously, the panelists will not be able to send you their answer. This webinar is being recorded and will be available to watch on demand via the original registration link later today. There is 1 hour's CPD credit for those who complete this webinar live. CPD certificates will be issued later today. You can only qualify for a CPD credit if you are watching via your own registration link. So that's enough of that. Let's crack on. Abdullah, can you open your mic and camera? And James, it's over to you to drive the presentation.
Hello, good afternoon. My name is Abdullah, and for Dassault Systèmes as a business value consultant, I focus on communicating the business value of the transformations and solutions we bring to the table for the architecture, engineering, and construction industry. Having experienced my fair share of rework, inefficiency, adversarial relationships between clients, and information clarity dearly missed on site, I'm happy to share our vision and solutions that are delivering great value across the globe with the audience here today. Next slide, please. So we have a with our very my expert colleagues here on the call today, we've created a great presentation for you. We'll be talking about the challenges we face, and then starting with the design end of things, moving on to the manufacturing and construction phases of asset delivery. We'll try to see how this all could comes together, and then of course we'll have the Q&A session. Next slide, please. And the next one. Yeah. So we're just at a time where we hear a lot of people voicing similar things. The industry knows what is being done right, and we experience many of the problems firsthand. Attending industry events around innovation, industrialization, and digital technologies in the built environment, you hear the needs of the industry loud and clear. And clearly, we could do better in connecting these fragmented workflows we have, sharing appropriate data with purpose, serving the level of information need, rather than recreating our own version of the same data at different phases of the asset lifecycle. The disjointed process between architects, designers, engineers, manufacturers, and the people bringing it all together on site is working against our collective budgets This is both in monetary terms and environmentally. We lack feedback loops. We do not connect the experience we gather on site back to the design process or the manufacturing process, and we see approaches like, you know, it will get sorted out on site and pushing the can down the road. We have configurability bottlenecks. Managing customer variations becomes challenging without escalating costs and timelines. And we often see the digital models do not necessarily translate to executable plans. Building information modeling BIM often stops at design, lacking integration with planning, logistics, and installation. So in the next slide, I want to talk about some of the challenges in the industry. We know that we are not doing well in terms of safeguarding the environment. Buildings account for nearly 40% of carbon emissions globally. A quarter of the life cycle carbon emission of a building is embodied carbon. The rest 3/4 are operational emissions. We know that concrete and steel and other construction materials are our largest contributors. Clearly, we should use less of what we use it more effectively, and reduce waste in all stages of our processes. We know that we've experienced, we have examples of this same chart on productivity from all countries around the globe. Manufacturing, advanced manufacturing, other industries have increased their productivity over time, whereas construction has stagnated, if not become worse over time. So clearly, there are people out there doing things right, and things are working for other industries, and we are yet to catch up. Another major trend globally is the skills shortage, especially here in the UK. We know our workforce is aging. We are failing to attract talent, and we simply do not have the workforce, the people to deliver the assets that we need. And we see this clearly in terms of both infrastructure and the housing shortage here in the UK and globally as well. In the next slide, I want to touch up on what success looks like. We do see success in other industries. We mentioned the productivity trends over time. The other industries have managed to increase both productivity and profitability. Amongst other things that they have gotten right, transitioning from engineer to order process to a configure to order process, has allowed these industries to leverage economies of scale, while technology has enabled personalization and customization at scale. A key enabler behind these industry scale transformations have been knowledge capture, reuse, and standardization of processes as opposed to the standardization of products. I hear this phrase, it's quite sort of wraps around nicely, standardizing the invisible and customizing the visible. An example many of us on the webinar today would have interacted with are kitchen configurators. Everyone gets to pick and choose, customize themselves a kitchen. Yet you can go to your favorite flatpack store and pick from the warehouse shelves a kit to assemble at home, a customized kitchen for yourself. Similarly, you see car brands, the automotive industry offering configurators. Everyone gets their personalized car. You see branding language there in terms of individual packs or autobiography or similar, emphasizing the personalization aspect. Yet we know that these all come from one manufacturing line. Another good example is on-demand personalized footwear. This example I have on the screen is from ASICS running shoes. So we know how shoe sizes work. They don't fit everyone, but by scanning scanning people's feet, you can they generatively create a insole that allows everyone to access a shoe that's custom made for their own feet, leveraging technology. We see this approach being applied in the shipbuilding industry. You see ship configurators that allow the same shipyard to deliver assets that serve many functions and come in all shapes and sizes. So today in this webinar, hopefully we'll be sharing how we can link all this together in the context of the built environment, and how we can maximize profitability in modern methods of construction. Thank you, and over to the next presenter.
Okay, good afternoon. I'm Gordon Stewart, product manager at Trimec. I have had some experience in industry with a company that was doing secondary steelwork, so it was quite often the lack of communication between the architectural systems and the engineering systems would often lead to issues, let's say. So let's just have a little look at that. So if we can go to the next slide. So in all building design, it's essential that clear communication takes place. So initially, it would have been through 2D paper layouts of the building. Alternatively, we could have built models out of wood or cardboard, so that would place a limiting factor on the design. And even when CAD starts coming in, we're still just using it as a digital drawing board. So we could do things, but still the collaboration was mainly through 2D paper, and everything was predominantly two-dimensional. But then we come across a project that forces a change, like the Guggenheim here in Bilbao, where we couldn't stick with those older methods. We had to use something new. So from an initial, somewhat unusual looking concept, that is the concept drawing, believe it or not, they needed to use something new. So they used CATIA, which have we seen before already, sort of automotive and so on. Industries is where it is large for, but clearly it was able to be used here. And even bringing up to the modern day, the Henderson in Hong Kong was used CATIA on the 3D Experience platform. And here it was vital that they could interrogate and analyze all areas of the building, be it from the finest details of the windows to how does the steelwork interface in with the steel cladding. So we have different people supplying data into a central source. Another instance was the initial build of the stair was completed. They did a scan of that stair on site, and that was fed back into the digital model. And they could then do a clash detection because the cladding hadn't been built yet. And here they could see that there was going to be a clash. So they had to make corrections. And by capturing that information, they could quickly re-edit the design because it's all just parametric. So we can just sort of tweak and adjust the skeleton. It's going to adjust the cladding there. And they knew then that they could deliver this on site without causing unnecessary delays. So if you want to know more about things like the Henderson building or the Bilbao, the Guggenheim in Bilbao, then there's the B1M channel on YouTube, or indeed Dassault have got their own video. I think that video is just looping through now, so we can maybe just stop that. But you can find content on our page. Now, a key advantage here is to make use of configured products. So here we can see a wall. Obviously, all buildings have walls, so this is, if you like, one wall to rule them all. So we control all the parameters. So if we need to adjust its strength, we can sort of make sure we can add or remove additional sections to it, or we can move openings to new positions. And we can basically have this template wall that we can place anywhere within the building. We can check whether glazing's in place or not. And if things get moved, it's not a case of a redesign process at all. It's just simply updating the model. And because we are controlling all the parameters of this, then there's no redesign work really. It's all just coming from this standard product. And it means that we're giving standard items to our shop floor as well. So we're not creating a series of bespoke tailored walls, it's all using standard operating procedures, so we can try and maximize efficiencies over there. Now, beyond that, because we're dealing in this fully connected system, we can also then look at things like the strength. So here we have a very simple wall, and we apply a simple load case to it. Now that could be for shipping or handling or lifting into place. Then we place our sort of template wall into our building, add the necessary openings, and that analytical model in Simulia, we can then just tie that into this new wall. So with just a few clicks, we can run that same study, that same sample study on this wall to check that it will withstand the loading that we've applied to it. Like I say, that could be for transportation, movement around the factory, or lifting into position within the building. So that we know when it's delivered to site, we're not going to end up with that unfortunate instance where a wall sort of collapses because it was lifted by the wrong points or something like that, lack of communication again, and leading to costly rework. And so because we've got control of all the parameters in our design in here, it doesn't matter how many doors or windows we're adding to it, what the strength characteristics are. We've got this tool that we can use to populate the whole structure from this parametric model. Okay, so I think that was roughly where that one finished. So if we go to the next slide, nope, yes, it had finished because it started back at the beginning again. Okay, so the next thing is then the interfaces between different disciplines. So again, we're dealing in this one environment here, so we can start off with a typical process with the steelwork, getting all the beams and so on in place. And then from there, we can start adding additional items. So we start adding in walls. Now it's just a generic sort of brick shape, cuboid, but we bind that to the steelwork. So if we have to change anything later, things will update. Now, once we've added in some of those items, we can then tell it how they're actually going to be manufactured, because we've got our configured products in the background. So is it steel stud work? Is it timber framing? We can cover all options in there. And we are controlling all the parameters again. So if we need to adjust anything, it's just a case of changing a dimension and the model will stretch and adjust to suit. And drawings will be updated in a similar way. Now, if we need to add additional equipment into the design, again, that's not going to really be a problem here, because if we set up a catalog of standard procedures in here, then we know that if we add in something like this duct in here, it's going to add in the necessary additional panels to hide that out of the way. And once again, the parameters mean that if we need to adjust this, it's just a case of pulling it into a new position, and the design will update to match our particular requirements. And we can make quite significant changes. So adding in the openings into what seem to be a flat wall is absolutely fine, be it doorways, windows, etc. We can add all this in, and we are in this same environment, so we can always communicate between the people fitting the doors, the people building the walls, people designing the steelwork. Everybody's working on this same centralized data. And because everyone's talking to each other, then you can't have a brainstorming meeting where people try and cast the blame to whoever's not in the office at the time. So everything is updating here. So it doesn't matter how things need to shift and move and adjust. The model is going to update there with us. Okay, so it doesn't matter if the ventilation engineers had to shift that around. The fabrication team are going to know, and everything will update. And even major changes like this, the whole footprint has modified. It's not a problem here because we're controlling all the parameters. Everything is controlled in here. So then we just need to update the model. You'll see everything just start to propagate through. Things will stretch and adjust, get cut back. The doors are all repositioned. We can then reproduce or republish the drawings for our shop floor. So making sure that everyone is always getting the right information and everything is being kept up to date with the minimum amount of fuss or the minimum chance of any, to minimize any chance of miscommunication or mistakes creeping into the system. Okay, so I think I will pass you on now to James.
Just there we go. Thank you, Gordon. I think actually what maybe next is a poll question.
Yeah, okay, James, I'll launch the poll if you bear with me a second. It should be popping up on everyone's screens right about now. I'll read it out just for the sake of making some noise rather than have dead air. So the question is, which capability below would most impact your profitability? Design for faster turnaround, level of information, managing complexity, variability, configurations, traceability, prefab manufacturing, layout, workflow optimization, site operations, thinking safety, logistics, coordination, people, the skills, the training, the attracting talent challenge we all face, or of course, all of the above. So I can see the answers are rolling in. Possibly about half the audience have done that for now. Do any of the panelists want to say anything about those answers or the question? While we wait, we're up to about we're over half of the delegates have answered. Howard?
Yeah, I think the one that I heard the most when I was at Digital Construction Week was the comment around safety, and probably I think safety impacts every single site, every single manufacturer, but perhaps less prevalent at the 2D drawing end of things. I'm sure people will have a view on that.
Yeah, okay, thank you. So we'll just give it a couple more seconds. We'll wait till it says 2 minutes on the poll. So it's time's counting down. You've got 20 seconds left. So which capability below would make the most impact on your profitability? So 2/3 of you have taken part so far. So if I can just get a few more to answer, that would be great. And I think we'll call it there for the sake of time. I will click end poll, and I will now share the results.
Oh, wow.
So they should be coming up on your screens. Briefly highlight that 51% went for all of the above. And the next most popular was design at 14%. And then Howard, perhaps reflecting your observation. Well, the site operations sort of comes in third. That incorporates safety, then managing complexity, then prefab manufacturing and people. James, do you want me to keep that open or shall I close it?
You can keep open in the background if it's still going.
I think I'll just it'll get in the way of your presentation, so
okay.
I'll stop sharing it for now. We have
no problem. Cool. So yeah, so jumping in, if we're happy with that.
Yeah, all right.
So thank you for all doing the poll. That's really interesting. Very interesting that it's 51% for all. So I'm going to talk to you a little bit about the actual building phase within construction. So this is interesting thing for this sector is it's not just construction on site, but obviously here you have the prefab off site as well, or hopefully some of you do as well. And so I'm James Brown, head of digital manufacturing. I've been very fortunate to be doing working with a lot of leading companies in this for the last 6-7 years, at the forefront of some of the fantastic projects. If you're here, thank you very much for letting me do that. And this is going to give you a little flavor of what that is and some of that secret sauce. So the first thing I want to show you is really that high level solution architecture, like when we're talking about the build for site. So how do we do that after this? There's awesome design stuff that Gordon was showing us a second ago. So that is obviously the number one step here. So we'll jump straight in there. So this could be CATIA, could be other elements as well, but obviously CATIA is fantastic. And then what we do is we take that and we'll go straight into our make or buy. So this is really the first part where we're going to think about our supply chain, what we're expecting to receive, what we're expecting to get out of our factory, and all of those requirements, which I'll explain a little bit more in a moment. We then jump into our process sequencing. So this is now with those items, what sequence am I actually going to build it in? So Gantt charts, things like that. Hopefully everyone's fairly familiar with that in the industry already. If not, there's definitely a place to start maximizing productivity. And then the new part for me, which quite often in all the businesses I go into, is looking then at, we've looked at the what, we've looked at the sequencing, now we're going to talk about the how. Like, what is actually fulfilling that process? Who is doing it? How many people are doing it? What equipment do you need? What resources do you need? And how do you actually turn that thing into reality? So we can start to communicate. Again, a key word here is communicate. Can we actually build this thing in the factory? And can we actually build this thing in the field? That's where our glorious step 6 on my screen comes in, where we can start discussing DFMA. If you're not familiar with that, it's Design for Manufacturing and Assembly. Effectively, what we're doing in that DFMA is we're going to look at clashes, like can our product fit through our factory? Can our product fit on site? How are we craning it into position? Can someone get in there and do the job? Which links very nicely into safety. Layout optimization is, for me, fairly obvious in a factory. How do we make sure our flow is good? How do we make sure everything can actually work? And the first time you get to your third station, it's actually going to clash with everything now and not work. And the same is true for site as well. How can we lay out things on site to make it work and be efficient, which quite often is something that is missed. You can see it every day walking around the street. Site's just cluttered, absolutely cluttered with equipment. And then the last one for construction factories especially is looking at that rate assessment. Can we actually achieve the rate that we need for our sites? For example, Gordon showed some mind-blowing facades a minute ago, and they are built of thousands, if not tens of thousands of panels. Can our factory actually produce those panels in time for our site consumption? So there's some really tricky questions there. And then right at the top, if eagle-eyed of you may have noticed I missed this, work instructions is then our final thing of how do we then communicate this to the people on the shop floor and the people in the field. So very important. So I'm going to jump ahead. If I can find my mouse to go to the next slide. There we go. And talk a little bit more about make or buy. So for me, this is really what we call manufacturable materials. So this is a really common term in other industries and quite often is not well known in the construction sector, which hopefully will change that today. Being a newish term, what do I mean by it? Effectively, this is our make or buy. So this doesn't impact your engineering bill of materials. This is completely separate to your EBOM. And this is really our first handshake, so to speak, between design and manufacturing, because you don't want your manufacturing team changing all the structure and all the method of how your design is laid out, but they may need it laid out in a slightly different way. So that's where this MBOM comes in. Again, think of this really as make or buy. So for example, if what are we making? Are we making the frames out of steel beams, in which case we're buying the steel beams in, or maybe we're rolling studs or something ourselves, in which case we're buying coil in. Maybe we're buying timber to build this frame. And then again, looking at the buying, it could be the windows, the doors, could be the entire frame itself. We decide actually that's too much manufacturing for us. We're going to subcontract that work out. Why is this important? How does this affect profitability? I do this as the first point in any engagement with loads of construction prefab businesses. And it's really, really key to, again, using this word again and again and again, communicate what are we actually buying and what are we actually making. And everyone says they know until we see it visually, and we go, I actually meant we're going to make this part of the frame, but we're going to buy that part because it's a special part for the windows or the facade. That part's just bought in and we're attaching it. So it's instantly a way to communicate well in your own company, but also to owners, to your general contractors, and to your subcontractors internally as well. So moving on to the factory. So why is this important? So everyone knows, or hopefully most people are aware, when we talk about a factory, there's some obvious gains to be had there. If we move to a factory, we can get regular shifts, we're independent of the weather, and we have all of these great factors that should make us more efficient. But again and again and again, if any of you look at the news, you'll see repeated companies who are doing prefab that go bust. And why do they go bust? In my humble opinion, talking to lots of these businesses, it's because they're often optimizing too late. Imagine, to give a bit of a story here, imagine if a aerospace or an automotive company, let's say JLR or something like that, had this amazing design for the car, and the first time they thought about the manufacturing was when they've bought all the kit for the manufacturing and the product enters the line. You'd have no doubt in your mind there'll be problems. There's going to be questions, there's going to be things that don't work, places people can't reach. Yet quite often we do that time and time again in construction, where the only thing we're really doing is like Excel or 2D CAD or things like that. So what do? We quite simply design the factory. So we can use parametric products similar to like Gordon showed before, but these are parametric factory elements like staging, tooling, shelving, things like that, to very quickly lay out the line. Through that, we can start to see where there are clashes, where there is reach issues, and get an idea of this is what our idea is for the line. Do we all agree? Does the factory superintendent agree? Are the product owners happy? Are the workers happy? Can we reach? Can we get in there? Is there some equipment we haven't thought of? So we're really getting into a lot of those DFMA style questions here to try and get our factory right first time. And I made a note here which I didn't say, because the key thing here is the best time to maximize your profitability in a factory is to make those optimizations and make those optioneering before you buy the equipment and hire the people to go in the factory. At the point you've bought it, it's too late. You're in too deep. You're now going through a change process, which will be inevitably expensive. So moving on to on-site. So as I mentioned before, you're in an extremely difficult industry. Which I hate to break it to you, because you not only have prefab in a factory, you then have this beautiful factory designed, flowing, great. It's efficient, it's profitable, but now you have to go to on-site as well. And this is a place we're more familiar with, thankfully, but we have to go through all of these same steps again. How are we building it? When we're on-site, what are we actually doing? How does the product arrive? How is it getting to the location? A second ago, you may have seen a telehandler, a crane, and a mobile crane. There's multiple different methods to do the same thing. Which one works best for us on this site? Because you don't want to find that out on site that you've picked the wrong one. At that point, again, it's too late. So how do we do this? Again, we just simulate as we go through all of the processes for what this looks like. Some of you may be thinking, oh my God, my sites are huge. Are you telling me I need to simulate every single panel being installed on site? Not at all. The key thing here is if we have repeat products, what we're trying to do is simulate the processes with those products. For example, this is an internal wall. It could be representative of external facade wall or something like that. We simulate it once. We understand the processes related to it. We understand the optioneering related to it. And then when we look at our entire site deployment, we can start to see actually 90% of the site that standard method works. And this last little 10% is really tight. That part looks okay. We've checked it and it looks good. This part is a big problem. We need to rethink our process, buy some new equipment, and you solve this before the fire happens on site. So it's trying to eliminate or predict firefighting effectively, which I'm sure never happens on the sites of the people here. Cool. And then my last slide, pleased to know, was really just touching on that DFMA point again. So I mentioned a second ago, I've got some things on site here. So this is actually the Everton Stadium in Liverpool, where we were looking at that facade panel. So doing this for real now, how are we actually installing that? So first, understand the processes. What's the bolts? How are we getting there? What do we think is going to happen? We then simulate it to say, can we actually do that job? And then off those simulations, we could see if this thing can reach or not reach. Eagle-eyed of you, especially anyone that's safety in the call, will see a safety hazard on the left, and you may see a safety hazard on the video on the right as well. And that drives discussion to say, well, how are we going to solve this? In this case, it drove changes into the product. It drove changes into the equipment that was working. It meant the whole team could see it, believe it, discuss it, and make those changes early to make the deployment more profitable on site. If you're not doing DFMA, to not be talking all day, please start asking how are we actually going to build that thing and what is going to build it. My 2 key questions for you to take away from this session.
We're gonna wrap up there. Okay, simply remains for me to say thank you to Dassault Systèmes for supporting this webinar, and thank you very much to Abdullah, Howard, Gordon, and James for your time and input this afternoon. Thank you very much.
Thank you.
Thank you, the audience,
Thank
for
you.
tuning in.
Thanks for the great
Thank you.
questions.
Thank
Thanks,
you.
everyone. Thanks so much.